Assalamu alaikum guys, welcome back. In this video we are going to learn about atomic structure. Okay, this is lecture 9 of our AS chemistry series. Okay, atomic structure, I'm not going to give you the definition first. I'll give you the definition after we learn how to calculate the atomic structure of an atom. Atomic structure, sorry, not the atomic structure, the relative atomic mass of an atom. Okay, relative atomic mass, as the name suggests, atomic mass of an atom, but relative to something, relative to a standard, as compared to a standard. Okay, and we are going to learn about that in just a bit. Okay, so let's get started. All right, so first of all, we should be able to understand how to calculate the relative atomic mass of an atom. Okay, so in order to calculate the relative atomic mass, the information that we need will come from the mass spectrometry. Okay, I'm assuming that you guys know what a mass spectrometer looks like. Remember that mass spectrometer diagram given in your books. Okay, that creepy sort of diagram having all of that stuff, the electromagnets and the electric fields and a beam of electron coming in and then deflecting and then hitting here and then giving all of that stuff. That's actually kind of irrelevant to our AS scores, Cambridge AS scores, because not the questions, in fact no question has been asked about the structure, about the design of the mass spectrometer. Okay, but although it's given in the books, so it's up to you to learn it or not, but this information is important. Okay, you should be able to analyze the mass spectrogram or this graph over here. Okay, this graph that has been given for percentage abundances against the masses. Okay, first of all, you guys should know what an isotope means. Okay, what is an isotope? Definition of an isotope. Isotope by definition are the atoms of the same element having the same proton number and different number of neutrons. Okay, and you guys have done this in your O levels, of course. Okay, so this is what a definition of an isotope is. Okay, the proton number has to be the same, the neutron numbers has to differ, and if the proton number stays the same, that means they are gonna be the atoms of the same element, because as long as the proton number is the same, the atom or the element is basically the same. Okay, the element is not different. Now this is a definition of an isotope, and you can have more than one isotope for a certain element. For instance, hydrogen has 3 isotopes. Okay, it has an isotope which has a mass of 1, the normal protium, then it has an isotope having a mass of 2, then you have an isotope having a mass of 3. This is called protium, this is called deuterium, and this is called tritium, and these are the 3 isotopes that we have for hydrogen. Okay, similarly you have certain isotopes for carbon as well, carbon 12, carbon 13, carbon 14. Similarly, you've got isotopes for chlorine, 35 and 37. You've got isotopes for bromine, 79 and 81, and so on. Many other isotopes that exist naturally. Okay, now the ones which are very important for us and that concern us are basically the chlorine isotopes and the bromine isotopes, because these have been tested tons of times on your past exams, on your past papers. Okay, so it's important for you guys to learn the percentage abundances of the different isotopes that are present for chlorine and for bromine. Well, the fun thing, or I should say the best thing about these two is that they only have two isotopes. Okay, they do not have more than 2 isotopes in here in our syllabus. So chlorine 35 is 1 isotope. Chlorine 35 means its mass is 35, and chlorine 37 is the second isotope that we have. Okay, now over here in this graph over here that I have given you of percentage abundances, percentage abundance means the percentage of that isotope that exists in nature. For instance, if you have, let's say 10 grams of bromine, in that 10 grams of bromine there is a 50% chance that you will get a bromine 79 and a 50% chance that you will get a bromine 81. Okay, different isotopes, because their percentage composition or percentage abundance is 50-50. Similarly, if you take a sample of chlorine, there is a 75% chance that you will get 35, chlorine 35, its relative atomic mass being 35, and a 25% chance that you will get a chlorine 37. Now guys, This percentage abundance is very, very important in order to calculate the relative atomic mass of chlorine or for bromine or for any element that's out there. Okay, now I'll take the example of chlorine and I'll explain you the methodology of calculating the relative atomic mass. Okay, on the x-axis you've got mass to charge ratio. Mass to charge ratio is basically nothing, it's just the mass of that particular, it's the isotopic mass of that particular element. Okay, isotopic mass is also the second definition that you should know. What does isotopic mass mean? Isotopic mass is not average, it's not weighted. Okay, this is not an average mass. Please write this down somewhere, that isotopic mass is not the average weighted mass. It's not an average, but rather it's the actual mass of that particular isotope. Okay, so what's going to be the definition of isotopic mass? Isotopic mass by definition means the mass, it is the mass of a particular, of one atom of that particular element or isotope of an element, particular isotope. Okay, this isotopic mass definition is important because has been asked for 2 marks several times on your exam. The definition of isotope is important because has been asked for 2 marks several times on your exam. And then the definition of relative atomic mass is also important, but I'm keeping it till the end because it's important. And then let's look at the methodology of calculating the relative atomic masses. Okay, so now over here, these are the isotopic masses of the 2 isotopes given to you, chlorine 35 and chlorine 37. Now guys, remember one thing, that in order to calculate the relative atomic mass, what you are going to do is relative atomic mass equals, you're going to just multiply the percentage abundance with the isotopic mass and add the product. Okay, and do the same for the other one and add both the products. So I'll just explain it over here. 75% means 75 upon 100, right? Because the total percentage is 100, and you are going to multiply that with 35 because 75% is the percentage abundance of chlorine 35. So you just multiply it with 35 and then add it to chlorine 37 percentage abundance is 25%, so 25 upon 100 and multiply it with 37. Okay, now as soon as you do that, you'll get a final answer of 35.5, and this 35.5 now, it's the relative atomic mass of chlorine, and that's the answer that you'll get when you look up your periodic table given in your data booklet. The relative atomic mass for chlorine is actually 35.5. Now let's come to the definition of relative atomic mass. Now, we've looked at the methodology of calculating relative atomic mass in particular for chlorine. Now, coming to its definition. So, relative atomic mass by definition is the average weighted mass. It's an average, okay? Isotopic mass was not an average. Average weighted mass of all the naturally occurring isotopes of the isotopic masses of all the naturally occurring isotopes of that element, of an element, weighed on a scale where each atom of carbon 12 weighs exactly 12 units. Alright, so basically what this definition is telling you is that it is the average weighted, relative atomic mass is the average weighted of all the isotopic masses of all the naturally occurring isotopes of that particular element. In this case, the element is chlorine, and the naturally occurring isotopes are chlorine 35 and 37. So it's the average of all the naturally occurring isotopes of an element, and these isotopic masses, these have been weighed or these have been measured on a scale where each atom of carbon 12 weighs exactly 12 units. This carbon 12 is the standard of chemistry, okay, standard for calculating relative atomic mass. So this has been standardized over here, that one atom of carbon 12 will equal how many units? It will equal 12 atomic mass units, okay, 12 units. So that's why this is the standard. Since we are comparing the masses of all the isotopes to the carbon 12, that's why the name is relative atomic mass. Okay, it's relative to the mass of carbon. It is compared to the mass of carbon 12. This is our standard of that scale. Okay, this is the scale that we have used over here. This is the scale which measures the mass of the different isotopes over there. Similarly, you could call the isotopic masses as the relative isotopic masses as well, because they have been measured relative to the carbon 12 atom, okay, but generally it's just isotopic mass that usually is asked. And this, okay, and there's another way to represent this graph over here. It can be represented in the form of abundance, okay, rather than percentage abundance. Examiner can give you abundance. How to calculate abundance on the y-axis instead of percentage abundance? Basically the abundance means that you have been given it from percentage to numbers, okay. So this number is 3 and this number is 1 for the smaller line. If you look at it carefully, this 1:3 is the same ratio as the upper one, okay. This was 25%, this was 75%. 25:75 is actually 1:3, right? The 1:3 is given to you. So you can use this as well to calculate the relative atomic mass. How? Well, you're going to just take the fractions. Simple as that. You're going to just use the fractions. Over here, the fraction for 1 is going to be 1 out of 4. Why 1 out of 4? Because the total is 3 plus 1 is 4, right? So 1 out of 4 multiplied by what? Multiplied by 37, and you're going to add it to 3 out of 4 multiplied by 35. This will also give you 35.5. Same answer, because the fraction is actually nothing different than 25 upon 100, and this fraction is nothing different than 75 upon 100. Okay, sometimes the examiner does give you a question in this format, so therefore I clarified it to you over here because it's important for you guys to understand it. And then comes the last part of this video, that is bromine 79 and bromine 81, how to calculate the relative atomic mass for bromine. It's simple, just use the same formula. Okay, it's 50-50, right? So 50% multiplied by the relative atomic mass of bromine 79 and add it to 50% of the 81, and the answer that you will get is going to be 80. Simple. That's the relative atomic mass of bromine. And by the way, the examples of bromine and chlorine, these are not just random examples. These are actually the examples which have been tested on the past year papers. Okay, so it's important for you guys to remember the percentage abundances of each of these elements, okay, both the chlorine and the bromine. That's all for this video, guys. Thank you so much.